Hello everyone. We're going to continue our lesson on 15A with some examples. So I'm going to just go down here. Okay, so our first example, y equals 3x squared. If I want to take the derivative, I'm going to factor out that 3. I'm going to apply the power rule to drop the 2 in front of the x and reduce the exponent by 1. And that's going to leave me with 3 times 2, which is 6x to the 1. We don't write the 1. Okay. For this example, we have 5 times root x. Now, whenever you see a radical, you want to rewrite it with a rational exponent. That means rewrite it with a fraction exponent. So this would be 5 times x to the 1/2. Notice I kept a y. I haven't done the derivative yet. Now I'm going to do the derivative. So I'm going to say dy by dx. And I'm going to use this notation because I'm starting with a y. This is the notation I usually use. If I was starting with an f of x, I'd usually use the prime notation. I'm going to factor out the f. I'm going to drop the 1/2, keep the x, and reduce the exponent by 1, applying the power rule there. And then I'm going to do two things. I'm going to multiply these two factors together to get my 5/2. And because I have a negative exponent, I'm going to drop the x to the denominator. Okay. Finally, I'm going to rewrite this fraction exponent as a radical. It's a little bit more professional to leave it that way. Okay. Over here, we have a fraction in our function, so I'm going to rewrite that with a negative exponent. Okay, we know some rules to deal with exponents, so let's rewrite this in exponential form. Okay, when I do that, I end up with x to the negative 3. Notice this is still the regular function. When I take the derivative, now I'm going to write that prime to indicate that this is the derivative. I'm going to drop the negative 3, keep the base, and reduce this exponent by 1. When the exponent is negative and I reduce it, it's going to get smaller to negative 4. And then I'm going to rewrite this without using a negative exponent. Again, it looks nicer without a negative exponent. Okay, this is a little bit of finesse that we'll work on throughout the semester or quadrimester. Okay, a couple more challenging examples. We have radical t cubed minus 7t cubed plus 6. So I'm going to rewrite these as in exponential form first. Then I'm going to apply my power rule and my constant multiple rules. So the derivative of s with respect to t. Notice this isn't dy by dx, but in this case, y is my dependent variable y is now s, and my independent variable is now t. I'm going to drop the 3/2, keep the t, and reduce the exponent by 1. Factor out the 7, drop the 3, keep the t, and reduce the exponent by 1. And the derivative of a constant is always 0. Tidying it up, it looks like this. Okay, and then for example, f of x is 1 plus root x over x. We haven't dealt with fractions like this yet, but we could split this numerator, break up the fraction so that we have, 1 over x plus root x over x, and then we can simplify that a little bit. So I can now rewrite with exponents, x to the negative 1 and x to the 1/2 over x to the 1. Keep simplifying before I even apply my derivative. So remember that if I'm dividing two factors with the same base, I'm going to subtract the exponents. Finally, I have my expression in a form that I can use. Now I can take the derivative by dropping the exponent, keeping the base, reducing by 1, dropping the exponent, keeping the base, reducing by 1, and then some tidying up steps. This example F is also included in your notes, but I will not include it in the video. If you have any questions, feel free to email me. Thank you. Have a good day and stay safe.